So to get it started, first we will create a Google Colab notebook. When Google Colab, open a new notebook and import the necessary libraries. Libraries that we are going to use in this project are Pandas, plotly.graphObjects SGO, plotly.subplots, import make subplots. Subplots are needed when you want to create multiple plots in one row or multiple plots in one column. So that that's what we will do here. We will create a 2 by 3 layout, two rows and three columns layout. So first you will import these libraries. So import pandas spd and run this code. It will connect to Python compute engine and import these libraries for you. As you can see in Google Colab, we have not got any error. That means these libraries are pre-installed. We just need to import them. Next part is to get data. To demonstrate you this particular chart or this particular dashboard, I used this sample dictionary data, but this data is actually available here. This is hospital patient data, which was, you know, a complete tutorial of Power BI was also there. Four parts were there. So there I explained about this data. It's a simple data set where we have patient ID, department in which the treatment was going on, what type of treatment was it, who was the doctor looking at them, their gender, patient's gender, their age, how much cost was there for this treatment, how many days they stayed in the hospital, and after all what they went through, like when they recovered, what was the recovery score. Higher recovery score, 100, means patient was fully recovered or fully satisfied with the treatment. So to load this data, we will go to files, and from here we will upload this data to session storage. So we will just upload that file. So here is that CSV file. Let's upload. And now to read the data, we will write df is equal to pd dot read underscore CSV, and this file will be like this. So you can copy path and paste it here. So you have to remember every time you will reopen this, and suppose you need to rework on this, so you have to repeat this process. Now we can run, and if we write df.head, so we will get the same data. If when we are doing exploratory analysis, if we write df.describe, so all the numerical columns, their KPIs are described, like their count, their mean value, what is average age of these patients, what is average treatment cost, 79,698, how many days, so on an average they stayed 16 days, their average recovery score is 70, then first quartile, second quartile, third quartile, maximum, minimum, everything you can see. So this is how you can get the data. So now in our case we have got data directly from the file. Now we will create our KPIs. So in the first part, there were some KPIs like how many number of patients are there, what is average age of these patients, average stay days, average recovery score, average treatment cost. So everything that we were seeing in this describe, we are picking their mean values. So because it's a data frame, so out of this data frame we are selecting all the mean values of these different columns. So a simple way to do that is you just select that column and just write dot mean dot count dot sum. So this way df square bracket patient id, this selects one column, that is patient id, and then it will, the method n unique will find out how many unique values are there in patient id, because that is number of patients. Then their average age, so age dot mean hospital stays days dot mean. So in these square brackets, in double quotes or single quotes, you will write name of that column as it is given in the data set. So you will copy the exact data, average recovery score, average treatment cost, everything. And because there is a space, so that's why we are using square brackets. If a space is not there in column names, you can also write df dot name, df dot age. Those kind of things can be done. For example, because in age it is not given, so we can write df dot age dot mean as well. That will also give us the same value. So now we have these KPIs. So we will print these KPIs in the chart here as a text. Now KPIs are created. Now we will create our subplot layout. So our subplot layout, which is 2 by 3 layout, like 2 rows, 3 columns. So figure, first we are creating a variable called figure, where you using a function called make subplots. So in this make subplots function that we are writing, we are saying rows equal to 2, calls equal to 3. Then these subplots will be created. So for every subplot, you will need their respective title. So we have this sequence in mind. So that's what we are writing. Average recoveries by department, average recovery by doctor, average recovery by gender, average recovery score by treatment type and gender. Let's say if we combine both, an average recovery score by age and doctor, average recovery score by cost bin. So this is from this case where we did something similar. Average recovery score by treatment type and gender, we used a ribbon chart, where in ribbon chart we can use two categories, one in x-axis, one in legend, and it shows the rank. Here we will use something different. So that's what we can do here. Now here we create specs. What is this specs? This specs will tell you what type of graph it is. You can see all other type of graphs are xy, like here is x, here is y. Only this, for pie charts we have to use domain, type domain. Okay, so this is what you have to write. So if you have to create a pie chart, you will write domain. So this is first row. In first row, first chart is xy, second is xy, third is domain, because it's a pie chart, and all others are xy. This will create a figure for us. If we will type figure and run at this moment, you can see it is giving us all the empty titles, but yes, our 2 comma 3 figure is created. Now after creating the figure, we will now we have to put charts in it. So let's put chart one by one. So first chart is department. So what we have to do is we have to tell average recovery score by department. So we have to pick one categorical data and one numerical data. So we in these cases we do df dot group by. So df dot group by department, what will this do? This will create a group where the data set, the entire data frame will be grouped by department. And when you are grouping something by a category, then you will select a numerical value which is recovery score, and select its aggregate function. So our aggregate function is mean. So that's how we will find department wise average score. And when we use dot reset index, we are basically selecting those department names. So these department names will be there. So let me show you what this does. So if we write it like this, so it will give you a series where we have recovery score by every department. Okay, so if we just write dot reset index, or if we just write dot index, so if I write dot index, so it will give me a list. Okay, so this way also we can do that. or if I write dot reset underscore index, this is a method. So you can see now we are getting a data frame. So this is how, this is what we are doing. So first we are creating a data frame. Then in that data frame, we are using figure dot add trace. So this will add a trace in a figure, that figure object that we created, add a trace to the figure, which is basically a graph. And then we are writing go module. We are using go module, which is graph object. So we imported plotly dot graph object. Okay. So in graph object, we are using bar chart. And you remember we created XY charts. So we are saying X is equal to department dot department and Y is equal to department dot recovery score. So we are saying that this way we are selecting X series, Y series, and we are saying name is equal to department. And then you have to specify in your figure, you have 6 places. What are the coordinates? So row 1, column 1. This way our first figure will be created. And if we then write, let's try to do that. So now you will be able to see that average recovery score by department is there. So this is how you will add your first chart. So whatever type of chart you have to add, you have to write geo.bar, geo.column, etc. So we will learn that. Similarly, chart 2 is there. So in chart 2, I will create them separately, and then later I will combine the code that you already have. So here you can see figure dot add trace. Now df dot group by doctor name. Now we are doing the same thing because we have to tell doctor name wise data. We will write doctor name recovery score dot mean reset index. Here again we are creating the bar chart between recovery score and doctor name. Here we have swapped the position. So on y-axis we are keeping doctor name because we are going to use a orientation that is horizontal H, and this chart will be placed in row 1 and column 2. So once you will do that, now we have two charts. Okay. Here you can see we have cardiology and gastrology. So this will give you this horizontal kind of orientation. So this is how you will do that. So here we have chart 1 where we have department wise recovery score, and here we have doctor wise recovery score. So what we have done so far, we loaded data, saw its head, described the data so that we can understand average values of different columns, different numerical columns. We decided number of patients. We created a figure. We saw what this represents, and then we created the chart. I want to get rid of that, so I wanted to get rid of that. That's why. Now we have two charts. Let's go with third chart. Third chart is a pie chart for gender distribution. So df dot group by gender. This time we are selecting gender, its recovery score, its mean. Suppose you don't want mean, you want standard deviation, you want variance, you want anything. So you can write something like that. So you can use that particular KPI. Here also we are saying this will go in row 1 column 3. Here we are using go.pie. So graph object dot pie. In pie chart we have labels and values. So labels will be what? Gender, obviously male, female and other, and values will be the recovery score itself. In a bar chart we have XY, but in a domain chart we are using pie. We have labels and values. We have these two keyword arguments. Now you can see it is created. So obviously once we will create, or once we will add everything and do it one time, then you will not see them again and again, but this is what it is showing right now because we are running them again and again. This is kind of happening. Later we will create one chart, one plot, because in one chart we are adding these things again and again, right? So that's why it is kind of adding trace again and again. Then we have chart 4. So where we have again bar chart, here we have recovery score, and here we have said that bar mode should be group. So when bar mode is group, so because we have now two things, okay? So here in this chart we have we, we have px dot bar. So we are using plotly express dot bar here, not go dot bar. We are using plotly express dot bar, and we are using df, x as treatment type, y as recovery score, and color as gender. So you have seen two bars. One is in graph objects and one is in plotly express. So this time we are using the plotly express bar because when you have only x y, then you can use this. But when you have x y and some hue or some color or some category also, so you can use that category here. So this in category we are showing gender, and then you have to use your bar mode as group. So this is what you can do here. So bar mode equal to group. We are going to do a lot of these series where we are going to explain more bar groups and everything. So if you are interested in learning more Plotly Express, which is being used recently in many exploratory data analysis videos or exploratory data analysis projects, so you have to learn that. So please subscribe to our channel so that you can get that information from us. Then for trace in figure 4 dot data, so in figure 4 dot data, because we were adding trace, we will add trace, and this will be in row 2 column 1. Similarly, scatter plot also we are creating, but here we are using doctor name as a color. So this purple color, L Khan. So L Khan, M Patel is red color. So what is this showing? Average age. So here you have age, here you have recovery score by the different doctors where it lands in this scatter plot. So earlier we are using charts like you know here we were using charts like stack bar or you know ribbon chart, but here we are using scatter plot. And finally we have chart 6, recovery score by cost bin. So here first we are selecting cost bin. We are using pd dot cut. Now pd dot cut, here use cut when you need to segment and sort data values into functions is also useful for so we have into bins, and this function is also useful from going from a continuous variable to a categorical value. So for example, treatment cost that is given in the data set, this treatment cost is actually given like this. So you can see this treatment cost is actually given like a numerical value. This is a numerical value. But what we have done is we have created bins of this treatment cost. These bins are created like this. So we have segmented the entire treatment cost in 7 bins. So first bin will be 5,400 plus this 20,000, then this 20,000 plus another 20,000 and so on. So equal bin size of $20,000. So that's what we have done. Or another way is to cut them in 3 bins and call them low, medium and high. So it will automatically create a categorical column from a numerical column. So this is what we can do. In Power BI or other tools, what we do is we use switch function to do that. For example, recovery category is created. So we use switch function. If recovery score is greater than 85, excellent. Recovery score is greater than 70, good. Greater than equal to 50, average. So this is how we created that. But in case of Python Panda, we write simple df.cut or pd.cut, select your column, decide how many bins you want to create. Like in our Power BI case, we created 7 bins, and what labels do you want to give it. Then we are using cost, so we are now grouping by cost bin. Obviously this now becomes a categorical value. Now we are seeing recovery score by cost bin, and then we are doing add trace because this is a simple bar chart without any color, without any categorical value to be added. So here we are just using that. Finally, we will do layout formatting. We will create a title. So title, we are using the dictionary function where we are saying text will be this, x value zero point 0.5 and x anchor will be center. So this will appear here in center. Then show legend equal to true. If we don't want to show legend, we can disable it here, and height equal to 720, width equal to 1280, which is a standard height for 16 by 9 ratio. Template will be plotly white. Margin, we are using t is equal to 180 to increase top margin so that our KPI box can adjust here. Then we have, I actually tried various margins, 100, 120, etc. In 180 we got that. I will share this code with you as well so that you can use it in your projects. So this there. Then we have KPI text. In KPI text we are using a little bit of HTML and Python print format. So in bold text we are writing number of patients, and then for value we are using variable number of patients. Average age, 2 decimal places, 2f, 2 float. Average stay, average recovery score, average cost. And this NBSP is uh, code for space, HTML code for space. So that we can add equal space between them. Now annotation, we need to show this text also. So this KPI position, to adjust its position and everything, text will be the KPI text, X reference will be paper, Y reference will be paper, and X value like position of X is 0.5, Y is 1.12. Move slightly up to avoid overlap. Show arrow equal to false. We are not showing any arrow here. Font, we are using 13 pixel, color black. If you want to use any other color, you can use that. Aligning it to center. Background color, we are using this blue color. Border color, again this dark blue color. You can use any other hexadecimal code here. Border width 2, border padding 6, like so that it can 6 pixel padding from border. And then we are using figure.show finally. So once you will do all of this, let's say I don't want to show legend, so I will just keep legend as false. And once you will do that, now you have your final chart. So this is something that you can create. So we can now copy this because right now we have a different data. So right now data is updated. So now we have more values, and now we can see final data. So in therapy, in medication, by treatment type. So gender female, treatment type therapy, recovery score is 50. Gender female, treatment type therapy, recovery score is 82. So here we are seeing different values. So similarly here. So obviously You can see many more charts that we have created here. We have answered more than 25 such questions in Power BI. So it is a four-part series. You need to watch this as well. You will learn a lot from it. Here you will learn how to create the same or similar kind of thing in Power BI or in Python Pandas. So I hope you understood something from it. I hope you learned something new. If you are interested in this, you can ask your questions in the comment section below. We'll be happy to answer. Thanks once again. Have a nice day.